Okay. Yeah, so good afternoon all. So I think we have stopped, we are going to continue the problem from where we stopped in the previous class. So in the given problem, they asked us to calculate what is the thickness and the width of the laminated plates, so which is nothing but leaf spring plates, isn't it? So for that, they're given two important parameters. One is deflection due to the load, and the other one is what is the bending stress in the beam. Okay, based on these two parameters, so we have two formulas for this. One is deflection formula, so where deflection formula can be written like this, and the second one is bending stress formula. Bending stress formula can be written like this. Okay, so with these two equations, dividing 1 and 2, so we can able to calculate the thickness, isn't it? So finally, the thickness can be written as T is equal to L square into FB by 4E delta. Okay. So 750 square into 400 by 4 into what is E? 2 into 10 power 5 into, and what is delta, ma? The deflection of the given plate is 50. Okay. So by calculating this, you are going to get the thickness as a 5.63 mm. Okay, so 5.63 mm is the thickness of the laminated plate. Okay, clear? Right. See, after getting this thickness of the plate, you have to go through the statements. So what is the statement given in the problem? Let's see the statement. Yeah, in this problem, it was clearly given plates are available is multiple of 1 mm for thickness and in multiples of 3 mm for width. Okay, so what is that? So whenever you are considering the plates in terms of thickness, okay, so it should be multiple of 1 mm and width should be multiple of 3 mm. So by that you can add just 1 mm to the plate. Okay, when you got the thickness of the plates as some value. Okay, in the same way, when you got the width as some mm, you can have the multiple of 3 mm for getting the final width of the plate. Okay, so for this, how we are going to write with that statement, okay, which was given in the problem. So we are going to write it like this: to the nearest 1 mm, okay, as given in the statement, as given in the statement. To the nearest 1 mm, so I can take a thickness of the plate as 6 mm. Okay, so instead of 5.63 mm, okay, which is the nearest to 1 mm of the thickness of the plate, so I can consider the thickness of the plate as a 6 mm. So okay, so this is one. So what is the other statement which was given in the problem itself? See the problem. Assume the width to be 12 times the thickness. Okay, assume width to be 12 times the thickness. So that means you have to assume here with the assumption given in the problem, assuming width is equal to 12 times the thickness, 12 into 6, and the width of the plate will be 72 mm. Okay, so this is how the thickness and the width of the plates are going to be attained. And how to calculate the number of plates, as it is a leaf springs which are connected with a number of laminated plates. How to calculate the number of plates? So you have a formula to calculate okay, number of plates with the help of a bending stress equation. Bending stress formula. See, if you see the bending stress formula here, okay, so in this formula it was clearly given FB is equal to 3 by 2 times or WL by N into B into T square. After getting your T value, after getting your B value, you can calculate N from this formula. N represents number of laminated plates which are connected, okay, one by one. Okay, so let me go with a new page. So here we try to calculate number of plates. So let's calculate also the number of plates.
Sir.
Chapandamma. Yeah.
Sir, we can calculate through deflection formula also now, sir.
Sorry? Yeah, you can use even
Number of
deflection formula
plates.
also, Mark. What is the deflection formula? Deflection formula will be 3WL cube by 8ENBT cube. Even
Yes,
you
sir.
can use that formula also for calculating the number of plates. Okay? Because both are same. Okay?
Okay,
You can use anyone. Right? Let's use for bending stress formula
okay, sir.
to calculate number of plates. By using bending stress formula, where n is equal to, so which is an equation 2, isn't it? So n is equal to 3WL by 2FBT square. Okay, 3 into, what is the load given? 7,500. And what is length of the member? 750. So what is this 7,500? The load which is acting on the beam is 7.5 kilonewton. 7.5 kilonewton can be written as 7,500 Newton. Okay, by 2 into, what is the bending stress value? 400. And what is your B? Width of the plate is 72 into thickness is 6 square. Okay, calculate this. You will get around 8.14. Okay, so you can make it as 9 numbers. Right? Understood? So now your spring is supposed to be connected with the 9 number of plates like this. Okay, let me draw this. Okay, center you will have a this thing. So all these plates will be connected like this. Okay. Yeah. So here these plates are going to be 9 numbers. Okay. So this is something like a simply support, and load will be acting like this. This load is 7.5 kilo. Understand? Right. So this is how we calculated the number of laminated plates. Right. Now, not only number of plates, not only the thickness and the width of the plate, even they ask you to calculate what is the radius of curvature when the beam is subjected to bending. Okay, so this is a consolidated beam, isn't it? Okay, so I think in your strength of materials one, in a pure bending equation, okay, so I think you would calculated the radius of curvature with the pure bending equation. M by I is equal to sigma by Y is equal to E by R. Okay, let me write that and let me do the same. Next. Okay, after calculating the number of plates, hence the equation 2 can be modified. Why equation should be modified, Amma? Why equation 2 should be modified, I mean, why the bending stress is to be calculated again? See, in the problem, bending stress was given. Why I am calculating bending stress again? Why? Because the number of plates with the bending stress, you got 8.14, isn't it? With the given bending stress, you got number of plates as 8.14 with the bending stress of 400 Newton per mm square. But what you are doing here, 8.14, you are rounding up to 9 numbers, right? So when you are increasing the number of plates, what happens to the bending stress? Can anyone? You are rounding 8.14 to 9. By that, what happened to the bending stress if you calculate again? Will it decrease or increase?
Decrease, sir.
Very good. It will decrease. Let's see whether it will decrease or not. That is the modified bending stress. Okay. So, because very, very important, Amma, in competitive exams, they may ask you problems like this. They will give the bending stress. You have to calculate the modified bending stress by getting the number of plates. Okay. So now calculate 3 by 2 of 7,500 into 750 by N will be 9 into B will be 72 into 6 square. What will be your answer? So your answer will be 361.7 Newton per mm square. See, your bending stress got decreased. Why? Because you increase the number of plates from 8.14 to 9. When you increase the number of plates, what happens? Depth of the beam will increase. Avuna? See, total set ni I can consider it as a beam. Avuna? Can I call it as a beam, Amma? Yes. The total set I can call it as a beam, right? When the beam depth increases, what happens? Member will have a capacity to withstand the load, right? So by that, the stresses in the beam will get reduced. By that, the strength of the beam will get increased. Okay? Member lo unna stresses tagutai, member yokka bending strength increase avutundi. Okay? So that is how the bending stress got decreased from 400 Newton per mm square to 361.7 Newton per mm square just by rounding your number of plates from 8.14 to 9 numbers. Okay, this is the modified bending stress anamata. Okay, clear? Right. And finally, you have to calculate radius of curvature. Okay. Okay, why radius of curvature? Why we have to calculate radius of curvature? Why? Because this is a beam. Beam subjects to bending. When beam subjects to bending, it will have the radius. Okay, this radius of curvature is going to be calculated based on the pure bending equation, which is M by I is equal to sigma by Y is equal to E by R. Right? Okay. So in this, which composition we will, which parameters we will use to calculate R? We'll go with this combination or this combination. A combination wealth man easy R
Second part.
Is this or this?
Sigma by Y is equal to E by R.
Very good. Why? Because you know sigma, which is bending stress. You know Y, which is what is Y, Amma? What is Y? See, this is your plate. The width of the plate is 72 mm. The thickness of the plate
Central
is
distance.
6 mm. Y is nothing but
Central distance.
Distance from the neutral axis to the outmost layer. That is Y. Okay. Please try to remember. This is Y, 3 mm. Okay. Y ante distance from the neutral axis to the outmost layer. That outmost layer can be top or can be bottom. Why? Because it is a simply supported beam. The bending stress will be same on both the layers. Okay. So with this relation, sigma by Y is equal to E by R. Okay. Take your R out. R is equal to E by sigma into Y. What is E? 2 into 10 power 5 by what is the stress amount? Which stress I have to consider? Is it 400 or 361.7?
361.
Very good. 361.7. Okay. Into Y is 3. Okay. Your R is 1660 mm. Okay. So this is your radius of curvature. So what do you mean that? So if you take a beam, when it is subjected to load, okay, the beam will bend like this. Sorry. The beam will bend like this. Okay, right? Right? So So with respect to its center, so the radius of curvature is okay. This is how the radius of curvature is going to be calculated with respect to the center of the beam curvature. Okay. So this is what they ask you to calculate. That's it. Right? Understand? So చూడండి ఈ problem లో which parameters are very important? ఏం గుర్తుపెట్టుకోవాలి దీనిలో చెప్పండి. Only two formulas. One is deflection formula, other one is bending stress formula. That's it. If you remember these two formulas, you can able to solve any kind of. They may ask you to calculate thickness, they may ask you to calculate width, they may ask you to calculate bending stress, they may ask you to calculate radius of curvature. Anything you can able to calculate. Clear? Right? So these are the problems how they may ask in competitive exams or even in your external examinations. Okay? Right. Next, we'll go with the next problem. So which is on spring. Okay. Note down this. Very important, Amma. So this problem is on springs which are connected in series. Okay. Right. So note down, a composite spring has closed coil helical steel springs connected in series. Okay. Each spring has 12 coils at a mean diameter of 20 mm. Find the diameter of the wire in one of the springs. The diameter in the other spring is 2.5 mm. Okay. So you have to, as the springs are connected in series, because it was given in the picture, I will draw that. Okay. So one diameter of the wire is not given, but the other diameter of the wire is given as 2.5 mm. And the stiffness of the composite spring is 1 Newton per mm. Why it is called as composite spring, Amma? See, ikkada springs they didn't mention as series of parallel mention cheyaledu. Avuna? They just mention it as a composite. What do you mean composite? More than one is called a composite, right? So as it is connected with the two springs, it is called as a composite spring. Estimate the greatest load that can be carried by the composite spring and the corresponding extension for a maximum shear stress of 180 Newton per mm square, and the modulus of rigidity is given as 0.82 into 10 power 5 Newton per mm square. Okay, so that is the problem given, and there is a picture also for this. Okay, let me draw that while solving the problem. Right? Note chestunaranda. Right. So let me write down the given data. Okay. So problem number 7, right? 7 and I think. Yeah. Okay. So A.M.I.E. Sharma. So let me draw the picture first. Okay. So like this, there are two springs, W, right? So this is the first spring, and this is the second spring. The first spring is having a number of turns as 12. Okay, so this is S1. Okay, and this spring is also having the same number of turns, 12, which is S2. Okay, right. Let me write down the given data. So this is a two closed coil helical spring connected in series. Okay, so 12 coils at a mean diameter of 20 mm, right? Mean diameter of 20 mm. So find the diameter of the wire and the mean diameter is given as 20 mm, so which is 2 centimeters. 20 mm. Okay, right. What else given? So the diameter is given as 20 mm. From this radius will be 10 mm. Okay. What else given, Amma? The stiffness of the spring is given as K value icharu 1 Newton per mm. What is stiffness, Amma? Stiffness is nothing but what? Load per unit deflection.
Deflection.
Given as 1 Newton per mm. Estimate the greatest load that can be carried by the composite spring and the corresponding extension for a maximum shear stress. Shear stress icharu, which is tau 180 Newton per mm square. Okay, and modulus of rigidity is given as 0.82 into 10 power 5 Newton per mm square. Right? Okay, so this is the given data. Let me solve the problem straight away. Okay, so with the given data, right? So in general, when the springs are connected in series, you have to remember these formulas. These formulas chala important, amma. Please try to remember this. Enti, when the springs are connected in series, your delta will be equal to delta 1 plus delta 2. Idu gurtundali. Next one, equivalent stiffness will be equal to 1 by K1 plus 1 by K2. As there are only two springs, I am writing only for two components. Okay. Inka, what else? Total force will be equal to F1 is equal to F2. See, these are very, very important when you are solving problems on when springs are connected in series. Okay. Here your deflection of the whole springs will be deflection of this plus deflection of this. And the load will be same. Whatever the load carried by the first spring will be equal to the load carried by the second spring. Okay. And the stiffness will be inversion of stiffness of the first spring plus inversion of stiffness of the second spring. Okay. Right. Okay. So now in general, so what we have to know, stiffness K is equal to load by deflection. Okay. So load by deflection, nothing but n d power 4 by 8 d cube into n. How I wrote this? What is this, Amma? Can anyone? What is this? What is this? How I wrote K as n d power 4 by 8 d cube into n. This is what? Deflection formula of a ఎవరైనా చెప్తారా? What is n d power 4 by 8 d cube into n? Guys, are you hearing? వింటున్నారా అందరూ? What is that? ఎలా రాసింది చెప్పండి. See, you should not forget, Amma, the stiffness of the circular coiled helical spring when a cross section is circle. What is the stiffness formula? n d power 4 by 64 n r cube. Gurtunda? The same which I wrote in d form. Why? Because your r is equal to diameter by 2. Right? So that is how
Yes, sir.
this formula was written in this form. Okay na? Andekani meer em sir kotta formula rasaru anukoddandi. Okay? Right. So now try to write this as inverse law of k. 1 by k emotundamma 8 d cube into n by n d power 4. Okay? Now let's have this parameter Amma. S is equal to stiffness. Sorry. K is equal to stiffness of composite spring. Avuna? So which is 1 Newton per mm already given, right? K1 is equal to stiffness of spring 1, right? K2 is equal to stiffness of spring 2. Okay. Next, delta 1 is equal to deflection of spring 1. Delta 2 is equal to deflection of spring 2. Okay. So what is delta? Total extension. Okay. Which is delta 1 plus delta 2. Okay. These all parameters you have to remember, right? So now let me do problem continuously. Okay. So because it is very easy, so just you need to remember all these formulas. These formulas meeku gurtunnayante problem cheyadam chala easy. Okay. So with these only I just wrote all these parameters. Okay. Right. Let me take new page. 1 second. Yeah. So now it will be fine. Now please follow my this thing and the continuous nature chudandi. 1 by k is equal to w, but as k is equal to 1 given, okay, k is equal to 1 and deflection is equal to deflection 1 plus deflection 2. Okay, so as k is equal to 1, you can write k as 1 is equal to deflection 1 plus deflection 2 by w, right? Why? Because your stiffness value is given as 1 Newton per mm icharu kabatti, and delta can be written as delta 1 plus delta 2 and w will be same, right? So finally this can be written as delta 1 by w plus delta 2 by w, which is equal to 1 by k1 plus 1 by k2. Right. Let's see what is 1 by k1. 1 by k1 is equal to 8 d cube into n by n d1 power 4. See, if you see the previous formula, which I wrote 1 by k as 8 d cube into n by n d power 4. Ikkada 1 by k1 rastunnanu. For the first spring, what will be the diameter of the spring? It is d1. Okay. Substitute all the values. 8 into what is the diameter of the coil? What is the diameter of the coil? Is given a
20 mm, sir, mean diameter.
Mean diameter ent ichcharama 20.
Yes, sir.
Yeah, 20. 1 second. Yeah, and what is n? 12 by what is capital N? Let it be, because your capital N will get cancelled. No need to substitute here. Okay, into what is the D? Let us take a D1 as the first diameter of the wire, which is given as 2.5 okay, mm. So let me finish it fast. Only 10 minutes left. We can come again, no issue. Into 10 power 4 by n. In the same way, write for 1 by k2, 8 d cube into n by capital N d2 power 4. 8 into 20 cube into 12 by n d2 power 4. Do you know d2 value? No, you don't know the d2 value. Into 10 power 5 by n d2 power 4. Okay, so hence by adding these two, why? Because 1 by k1 plus 1 by k2 kabatti, add these two. 1 by k1 plus 1 by k2 is equal to 1.97 into 10 power 4 by n plus 7.68 into 10 power 5 by n d2 power 4 is equal to, what is this? 1 by 1 is equal to 1. Endukante 1 by k kada 1. Okay, from this calculate what is the d2 value. Can you do it? Idantha total calculate cheyandamma. Okay, you will get a D2 value. So finally, I will write down the D2 value. D2 as 1.874 mm. Okay, you can cross check it, right? So D2 is 1.874 mm, right? So the D1 is 2.5 mm and D2 is 1.874 mm. From this, calculate the bending stress is equal to.
Sir,
చెప్పండి.
sir, n value question లో ఇచ్చాడు కదా sir.
Yeah, n value ఇచ్చారు కదా already. You can substitute the n value. 0.82 into 10 power 5 Newton per mm square. Okay.
Yes, yes.
You can substitute them. You substitute and you can get this value as 1.874 mm. Ichar. See, one more thing, Amma. If people are not, I mean, in examinations, if they are not giving n value, don't worry. You can take n as a constant elastic constant of the spring. Okay, so which is the modulus of rigidity. Meeku andarki steel yokka modulus of rigidity telusu kada. So you can directly take that value if the value was not given in the problems. Okay, antegani don't nullify that. Okay, n anedi meer assume chesukovachu, which is an universal constant. Okay, so calculate the bending stress 16 W R by pi d cube of 1 plus d by 4R. Okay, so from this, so what happens for to be maximum? If I want to get the bending stress as maximum, okay, with that equation, so d is to be minimum. Antena? So when your bending stress will be maximum of the spring, your bending stress will be maximum of the spring when your D is minimum. Okay. So when the D is minimum, then only you can able to get the maximum bending stress. So as a D minimum, which D2 you got as 1.874 mm. Okay. So substitute these values here and try to get the values. What is bending stress given in the problem? Problem which are bending stress. Sorry. Bending stress cause maybe shear stress. I'm sorry. It is not bending stress, it is shear stress formula. Okay. Sorry. Shear stress. Right. What is the shear stress value given? 180 is equal to 16 into, you don't know the load, and radius is 10 by pi 1.874 cube of 1 plus 1.874 by 4 into 10. Okay, it will be around 0.81 W. Okay, na? So this is the load, 8.1 times of the W. Okay, then calculate what is W. 180 equal to 8.1 times of W. What is W, Amma? 180 is equal to 8.1 times of W. W is equal to 22.22 Newton. Okay, and what will be the deflection? K into W. K is 1, 22.22. Your deflection is also 22.22 mm. Okay, so that's it. So this is what they ask you to calculate. And then, so for the given problem, they asked what is the load acting on the spring. Okay, what is the total deflection in the spring? Okay, so as the stiffness of the spring is same as 1, the overall deflection will be 22.2 mm, where the load is also 22.22 Newton. Okay, so this is how you can able to calculate the load, stiffness, displacements, or deflection based on the shear stress equation and based on the conditions which was framed before the problem. Because the problem appudu frame chesamo, based on that you can able to solve it, right? So this is how we can able to solve problem on springs which are connected in series. Okay, right. Now show me the problem.
Sir.
Cheppandamma.
Sir, deflection formula W by K no sir.
W by
not
K.
K into W.
Stiffness ఏంటమ్మా?
Stiffness equal to load by deflection, sir.
W is
Deflection equal to W by K, no,
sorry,
sir.
sorry. Yeah. Sorry. ఒక్క నిమిషం. Sorry, I made a mistake, Amma. Sorry. How the load and deflection will be seen. Right. Sorry, guys. Yeah. So now see, deflection is equal to load by stiffness 22.22 by 1. That is 22.2. Sorry.
Sir, sir,
Yeah, చెప్పండమ్మా.
sir, ఇందులో D వాల్యూ ఉంది కదా సార్ షియర్ స్ట్రెస్ లో ఓన్లీ D2 సబ్స్టిట్యూట్ చేయాలా సార్? నో నీడ్ టు సబ్స్టిట్యూట్ D1.
కాదమ్మా, D2 మీరు ఎందుకు D2 సబ్స్టిట్యూట్ చేశారు అంటే D1 is the known value. ఓకే, D2 is the unknown value మనం క్యాలిక్యులేట్ చేసాం. ఎందుకు D2 సబ్స్టిట్యూట్ చేసాం అక్కడ చాలా ఇంపార్టెంట్ ఒక పాయింట్ చెప్పాను చూడండి. ఫర్ షియర్ స్ట్రెస్ టు బి మాక్సిమం D షుడ్ బి
మినిమం.
ఈ స్టేట్మెంట్ చూడండమ్మా. when your shear stress will be maximum,
when D is minimum.
D is minimum. Okay, what is the value of D1? 2.5.
2.5.
What is the value of D2?
1.8.
ఏది మినిమం రెండిట్లో?
D2 sir.
అందుకని అది సబ్స్టిట్యూట్ చేసాం. ఓకే
Okay sir.
Okay, to make your spring shear maximum. Okay, so అంటే దీని మీనింగ్ ఏంటి? You will get the maximum shear stress of the springs by taking your spring having a minimum diameter. అంటే ఏ springs కి అయితే diameter తక్కువ ఉంటుందో those springs will have a maximum shear stress. Okay, so that is the reason why people choose minimum diameter of the wires for the springs to have more shear stress values anamata. Okay, so with that note we consider the D2 as a minimum and calculated the load. Okay, right.
Okay sir.
Okay, so finally last problem I think. Yeah, so I request guys you to solve this problem as a as an assignment. Okay, so then I will tell you the 9th one and I will close the session. I think there is only 1 minute left. Guys, can you rejoin again with the same link? We will try to close 9th one, where 8th one will be your assignment from the first unit. Can you? Guys, can I continue the class? Guys, can I? Because I want to wind up springs today. We can
Yes,
start.
sir.
Okay, na? Right. Okay, all of you. Okay, then log out and please log in again with the same link. We will start doing one problem, and 8th one